So once you've completed the schematic, you can then start creating the actual PCB layout. So that's in the board file. So this button here, so because we've not got a board file, it'll generate one. So we create this from the schematic. And if you've already got one, then it'll just switch. This button just switches between the two. So by just pressing that button, we'll just switch between. The first time it'll create it. So you can see here, this is all our components are placed down. And this rectangle, so you see, sorry, the yellow lines as well, they denote those connections. So we just draw the electrical connections in the schematic. And in here, that's known as a rat's nest. So each one of these yellow lines represents one of those connections which we later need to route. This rectangle here is the default size of the board layout, so we can change the size and shape of this later. Yeah, so maybe for the time being, we can just delete. Actually, no, we'll keep it there just to give us something to kind of work towards, but we can alter the size later. So we go to the lab notes. We can see what the kind of thing we're aiming for. So I'm going to get the K64F. So this design, when I came up with this, I actually made a cardboard template for it. So I got a Xbox 360 joypad. I kind of worked out roughly the size and shape it would be on cardboard, and then put the K64F on it, the battery and things and so on, just to get a rough idea of the layout. What would be a nice layout in your hand. So I'm going to stick the K64F down. So now you can start use this move tool again. Once you pick it up, you can start rotating by right clicking. I'm going to rotate it when it's on its side. So the battery is going to go roughly underneath. So you cannot. There's a grid here. So you put the grid on. It will, when you zoom in by scrolling, you can see the grid lines. So I'm just doing this quite roughly now, but when you're doing it, if you're doing it properly, so you can use the grid tool. You can look at the positions. You right click on properties. You can get the positions. And you want to try and make the board symmetric. So I'm going to start roughly placing the components down. So the battery's on the bottom, then we've got our 4 buttons, so Y, X, so which side do they go? X, Y, and B. So you can see as I'm doing this, these wires are moving, so if you press the rat's nest, it keeps redrawing the wires to the kind of nearest one they're connected to. So when you're placing your components in general, you want to be trying to, you want to make the connections in the rat's nest as short as you can. Try and get roughly connected to where the pins are going to be connected to. Joystick's going to be around here somewhere. Put the piezo down. So you don't want to overlap. So I'm being very careful here not to overlap. So you look at these buttons here. So I don't want to place this button down with the 2 pads connected to the joystick, because that's connected to the battery terminal, because that's a short circuit then. I don't want to get things too close, because you need to leave gaps for tracks to run between. So it really is an iterative process. It's not just a case of sticking it down once and jobs are good, and you've got to kind of keep going back and rejigging things. It does take a while to do this. So you're quite lucky that I've already done it, so you're going to essentially copy from the design. When you come up with the original design, it can take a while. So put the power button down at the bottom. So here, also trying to bear in mind the physical location of these buttons. So the power button I'm going to put down at the bottom. I want to avoid, on the K64F, I want to avoid placing the things over in this white rectangle here. That's the USB port. So if you put pads over the top of there, you've got to be careful that when it's soldered in, those pads might touch the metal on the USB port. Oh no, it's an Ethernet port, not USB port. Cause a short circuit. So again, I'll move that up a little bit just to make it more symmetrical. So all the LEDs, so which number LED was this? LED 6, so we'll put that on the right. 5. So I'll keep pressing the rat's nest button, I'll just keep redrawing the rat's nest. So back button can go roughly around here, start button. So the left button I'm going to put at the top, right button. And those LEDs will kind of put roughly together. So here I'm just doing it roughly, but you probably want to spend a bit of time and care. So the LED ought to go on that side. So the resistor ought to go on that side. So you can see I'm rotating as well, so it makes sense when you put a component down. There's no point putting it in this orientation because then the track has got to go through the bottom red pad. So if you rotate, it makes the connection much simpler. So stick all those down. I'm going to print the logo on the board as well. So I'll put that down here in the middle. I'll press the rat's nest again. So that gives us a rough kind of approximation of how the PCB is going to be. So actually these buttons, so the left button and the right button we'll put on the bottom of the PCB, so we want them stuck up, we want them kind of underneath the PCB. So we can do that using the mirror tool, so mirror this object, and that's just going to mirror it, so that means it's now kind of upside down on the bottom. So mirror that as well. The battery is going to be mirrored, so the battery will be down on the bottom. So I'll just pick that up and now rotate it so it's back how it was. And we'll put the power switch on the bottom as well, so we'll mirror the power switch. So those are the components what are mounted on the bottom of the board now because we've mirrored them. So by default, when you put a component there, it's on the top of the board, so the component's on the top side. The through hole will solder on the bottom side. We'll also angle these buttons a little bit as well, so they're not vertical. We'll kind of put them so they point into the diagonally, so they're easy to press. So we right click, properties. So I'll try 45 maybe. That's wrong. So that'd be 180 plus 45, 225. So that's pointing that way. We can do this one. So there, those components are at an angle. So you might want to tweak those. Now we can start trying to resize this dimension. But so you can, you pick the corners. You could we can move it and resize it. But we'll put some nice curves on as well. So this mitering tool here. So you click the miter tool. And it makes it a round one. On the corner you can drag the board in, so I'm going to drag it in there, trying to not get too close to the pad. So we can, in fact, we have to move this up because these pads are on the longer dimension. We have to lift that up. I'll just undo that to lift it up. Let's maybe try something like this. And bring that in. Same here, so you want to be trying to get symmetrical. These corners try and kind of lift up so you can do those curves. So if you do want to draw the dimension line in manual, so if you're going to delete the existing dimension line and start again, you'd use a draw tool, but the dimension layer is in this the layer number 20. So if you select that and draw a square, so you can change the thickness and so on here. But normally the dimension layer is drawn in thickness 0. So you could manually draw the size of the PCB with 0 width line in the dimension layer. So you can do it that way. You can just resize the existing one, whichever you want to do.